Hello and welcome to this RapidMiner tutorial. In this video, we'll show you how to fully automate your model selection and parameter optimization. We'll start with the process we created in the parameter optimization video. As always, if this is the first video from our series which you're watching, then you can download the process and the data used here from our website. The video on data loading via a process will show you how to import the data and the processes. Now back to our process here. In this process, we're optimizing the parameters of a decision tree algorithm, but during the tutorial on model selection, we saw that also random forest and rule induction are performing well on this example set. If we were to optimize the parameters for either, then one of them might actually perform better than our decision tree. To try that out, we could now swap out the decision tree here in our cross-validation manually, but that would not be elegant as we would need to repeat this and reconfigure the optimization each time for any of the algorithms we're testing. So, a much smarter approach would be to leave this one as is and use copies to create one parameter optimization with a random forest and a rule induction. Through the magic of video editing, we will jump right to the end of this copy and pasting. As you can see, we removed the log operators here and have also updated the parameters which we will use to optimize. For the random forest, for example, we chose to iterate over the number of trees. For both the random forest and the rule induction, we chose only one parameter to be changed. We specified only 10 steps for each, as we want to keep the time for our demo process to run very short. In your real case, you should consider doing a wider and finer selection, but keep in mind that the process may take some time to finish. By the way, since version 7.3, we've started to introduce parallel execution for some operators, which gives you a lot of boost as it uses multiple cores on your computer at the same time. Before we move on, let's just briefly save our process here in the repository. I'll just give it a new name and all set. Okay, now if we want to perform all three optimizations on our data, we could achieve that by using the multiply operator. But then we would need to look up the performance for comparison by hand, which is again not very elegant. After all, it is our goal to find the best model after optimization in an automated fashion. To automatically return the model with the best results, we'll use yet another optimization. As varying parameter, it will have to iterate over the three parameter optimizations, which we can execute using the helper operator, select subprocess. Okay, let's do this. We drag in the select subprocess operator from our operators panel into the process panel. Then we cut the parameter optimizations, and then we paste them into the subsections using, for example, the right mouse button. Since we have three optimizations to trigger, let's add one more selection window. Next step is to connect the operators. And now we can embed this nicely into another grid optimization operator, which will then return the highest achieved performance of either of the embedded parameter optimizations. To make sure we're not only getting the performance vector, but also the info on which model was selected, we can also connect the parameters port, here, to the results. Of course, before we now run this automated model selection, we need to specify what to optimize. As mentioned before, the varying parameter is this time a subprocess, and not a parameter per se. Therefore, it is only 1 to 3 here as we have three optimizations as subprocesses. And we will do those in 3 steps. All right, now as I select Run Process, you can take a look at the lower left here to see how the optimization iterations are performed. Good, the process is done and the results view is displayed. The best performance achieved by one of our 3 parameter optimized models is roughly 85%. And the model with the best result was in the subprocess 1, which is the decision tree. If we look at the ROC curve of the performance vector, then we see that it is really nicely getting close to the upper left corner, which is where the perfect model would be. Now, if this is the first tutorial you're watching in our series, then we recommend to have a look at the model selection video to learn more about the ROC curve and its interpretation. For those of you who have already watched it, you may remember that we did mention in there that we were only looking at unoptimized ROC curves. So as last part of this tutorial, we want to show you a way how you can change that. All right, let's go back to the design view. The current setup only outputs the information which is the best performing subprocess, but what we're looking for are the optimized parameters for each model, so we can plot rock curves for comparison. We already generate the parameters for each of the individual optimizations with our current process. We'll just need to make RapidMiner remember them for later repurposing. And so remember is exactly the keyword we can use to find our next operator. Now let's drag and drop it 3 times and give each of them a name. I'll use abbreviations here to keep it short and sweet. We also need to make sure we select parameter set as the definition of what we want to remember. With that, we're ready to go back to the main level of our process, where we reactivate the multiply and the compare rocks operator, which were sitting there now for a while. First, we connect them, and then we take a quick look if the sequence of execution is right. Yep, okay, all good. Now we've asked RapidMiner to remember all the optimal parameter settings. Hence, it is not a surprise that the next operator to use is the recall operator, while we execute our compare rock operator. We'll remove the models which we don't need anymore, and then drag and drop in a recall operator. The name we use to configure it needs to be exactly the same as the one we used for labeling remember parameter before. It was DT for decision tree, which we used, and we want to recall a parameter set. And in order to apply this to our decision tree model here, we will finally use the operator setParameters. We need to establish a link by using the right name of the specific instance of the operator, so we'll change that for easier understanding. And now let's paste that into the settings of our setParameters operator. Again, we need to check if the execution is happening in the right sequence. Oops, here we need to bring recall and setParameter to the front so they're available before the decision tree is executed. Now I'll repeat all the same steps for the other 2 machine learning algorithms, but I'm not going to make you watch all of this, so let's fast forward. As you see, we're all set, ready to run this process. And finally, after a few seconds, we get our rock comparison graph showing the curves for our optimized models. It shows that the decision tree is the best model, which we already knew from our previous run. But now we can see that rule induction and random forest are a close second, depending on the threshold setting for the classification. As mentioned, please refer to the model selection tutorial to learn more about the interpretation of the rock curves. With this, we conclude our video on more advanced optimization, in which we showed you also how to select subprocesses and how to remember and recall certain elements in a RapidMiner process. We thank you very much for watching.